do this.
Never goes away.
Never. Hello, and welcome to the panel discussion of Stuart Russell's talk on Provably Beneficial AI. I'm Adam Weiner. I'm the program chair for ICAIL this year, and I'm hosting this panel discussion. What we will do is I'll make a few remarks just about Stuart Russell and a little bit about his talk and why I thought that it was relevant to invite him to speak to us. He was not able to come to us live because he had other occupations, but I thought it was still a very good idea for him to join us with some prepared material and then to have a panel discuss his talk. And then I'll make some brief introductory remarks about our panelists so you have an idea about who they are. And then we'll turn it over to each of the panelists for about 15 minutes for them to talk about their interests and this general topic as they see it. And then we will take comments from the audience. And please submit your comments and questions into the chat, which will then be transmitted and shared amongst the panelists for some further discussion, okay? So I'll say a few words about Stuart Russell, who almost doesn't need any introduction to the computer science community. Professor Stuart Russell is a professor of computer science at the University of California, Berkeley. He's the director of the Center for Human Compatible AI. He has co-authored with his colleague Norvig, probably the best known book in computer science, Artificial Intelligence, A Modern Approach. It's used around the world in computer science courses. It's really the standard text and it's a gigantic tome. So he's really very knowledgeable about AI across the board. He does research in a great many topics in AI. Most recently, he's really been focusing his work on this topic of beneficial AI or trustworthy AI or responsible AI, which has become a very significant topic of discussion over the last couple of years. I'll give a plug to his book. He's got a book called Human Compatible AI and the Problem of Control, which is for general audiences, but also, and this is partly an important point, from a computer science point of view. So then I'd like to just make a short remark about why it's relevant, I think, for the ICAIL community. So as I've said, there's a great deal being made about responsible or trustworthy AI, or whatever you want to call this. To a great extent, this is being made from, let's call it, an extrinsic point of view. That is, how does the law apply to computer science, to programs, to AI? So has an AI program done the right thing or the wrong thing? Who is liable? How are they liable? Very much seen from the outside and not necessarily with a great depth of understanding about AI itself, how AI functions, and about how the systems are developed or how they could be changed. So I would call this an extrinsic point of view, applying the law to computer science. We can contrast this with what we might say is the intrinsic point of view, which is how we build the law into an AI system so that it can conduct legal reasoning, compliance, so that the machine learning model accommodates human interests and human needs. This is, I think, a topic that's very much relevant to the ICAIL community, even if it's not a topic that's often presented and often of relevance. And Professor Russell's recorded talk really at the end references this idea of the intrinsic perspective about AI and about whether or not it's beneficial, okay? So I hope that you, as the audience, have all had an opportunity to have a look at that talk so that you're familiar with the contents and its themes. So then let me turn briefly to the panelists. I'm going to go in order, so they'll have 15 minutes each, but in the following order. So we have Professor Danishka Bolagala. He's a professor in computer science at the University of Liverpool. He leads the data mining and machine learning research group and also the natural language processing group. And fairly recently, I guess the last 5 or 6 years, he's been doing collaborations with AI and law researchers at Liverpool and elsewhere. So that's one of the key reasons why he's here. We have Emeritus Professor Tom Maybaum, who I've known for quite a long time. His last position was at McMaster University, but he was also at King's College London and also at Imperial College. So he's been at some very prominent institutions. His work is on theory specification and application in different contexts, in particular relevant to the AI and law community. He's done a lot of work on deontic logics and the application of deontic logics in a range of contexts. One of the areas that's particularly relevant, I think, and he'll speak for himself, but just to highlight this, is that he's done a lot of work on software certification for safety critical systems, nuclear power plants, medical devices, autonomous vehicles, and he's long developed this, I think, intrinsic point of view about law and computer science. So that's, I think, one of the key reasons why I thought he would be highly relevant. Then we have my colleague, Bertie Mueller, who's a senior lecturer of computer science at Swansea University. He's the chair of the Society for the Study of AI and the Simulation of Behavior, so multi-agent systems point of view. And he does research on agent programming, concurrency theory, Petri nets, and also formal methods. So quite relevant in those regards. So I hope that I've introduced each of you somewhat fairly. If you have more to say about yourselves, please, I'm happy to fill everybody in. Let me, with that, turn the floor over to our first panelist, Danishka, for his remarks, and I will hold my whatever else I have to say. Thank you very much. Thank you all three for participating with us in this. I'm very pleased that you took up the invitation.
Thank you, Adam, and thank you very much for inviting me to join this panel. I hope everybody can hear me well. So the first thing I got this invitation I did was looking at Stuart's talk, which was quite interesting even from my background. So I come from a natural language processing and applying of machine learning to NLP techniques. And there were quite a few areas which I thought from his talk that I could elaborate and maybe highlight so that we can have further discussions. So maybe I'll try to share my screen with these three monitors. Is it possible to see my screen? Yeah. So the first thing I found it quite interesting in Stuart's talk was that he was connecting this notion of uncertainty and using that as a way of, for example, preventing for example, autonomous agents such as robots. Pushing its power switch off and not doing anything else, giving some kind of a room for this agent to learn about human preferences and not letting the agent have absolute kind of understanding about without any uncertainty about the various preferences the humans would have. So this I thought was quite interesting even from a machine learning point of view. For example, this is a slide that's coming from his talk, where he was talking about assigning kind of multiple labels, in supervised classification problems, such that you can model things like uncertainty. Right now, when we do a lot of crowdsourcing for collecting labels for data sets that we can subsequently use for training models. We ask annotators to, for example, annotate images using a specific set of labels. So we don't encourage people to add uncertainty into our data sets because we think it's kind of harmful. We want the human annotators to be as precise as possible. Provide, for example, even if they're not sure whether it should be labeled as an image should be labeled as a cat or a dog, then we still want them to pick one label and annotate it. So this, I think, is kind of interesting way of looking at the problem. because if you let the humans, for example, to assign labels as he mentioned here, like, I don't know, I'm not sure whether this is this or that, but I know definitely it's not this. Like this type of feedback can be provided, then we could, use that to incorporate this uncertainty into like machine learning models as well. So I thought it was kind of interesting way of looking at data labeling. And also we tend to think, if there is some kind of a noise in this labeling task, then that would hurt, for example, the machine learning models that we build later on, so that would be a problem, and so on. So we emphasize quite a lot on things like inter-annotator agreement. And if two people don't agree on a particular label, we would most probably like throw that data point away if we have already like millions of other data points that we can use for training. So on the other hand, the fact that two humans don't agree on a particular decision, I thought it would be nice to actually, keep this in the data sets and let machine learning models also, learn from these type of uncertain decisions. So that was something like that I would, personally would like to, take on and do further research, in particular in tasks such as natural language processing, where there's a lot of subjectivity involved in labeling data. I guess this is also quite relevant for the AI and law community. We have seen recently lots of machine learning being applied for legal decision-making systems. And there again, not all for example, not everybody in a jury would perhaps agree on a particular decision. They might have their own opinions. So when we kind of create these legal data sets to build machine learning models, I thought we could preserve this information in the data, and again teach or kind of build machine learning models where this uncertainty in the labeling is kind of built into the model, rather than trying to throw it out as a kind of noisy data point. So that's something that I found quite interesting. And a second thing I again found quite interesting was this modeling of pride, rivalry, and envy inside agents. So this is quite interesting, especially in multi-agent learning settings, where you have multiple agents and they're all collectively trying to learn some kind of objective. And they might individually have different preferences. So I'm seeing these type of techniques being used in the NLP community. Try to, for example, when you try to optimize a system of a set of tasks where doing well on one task might kind of have adversarial connections to other tasks and so on. So this I thought was quite interesting avenue to look further into. So in his talk, Stuart was not specifically getting in, touching on the point of explainability of AI, kind of explicitly. But I think that's also something that's quite relevant to this particular community, AI and law. Because we are building a lot of, machine learning models to make either legal decisions or to support the legal decision making process. But then we probably don't want to say this is a positive case or a negative case, but we also want to provide some kind of evidence or explanation as to why we are making this type of decisions. So again, I think there's a lot of work that as a community we need to do. Providing explanations into our machine learning models. Recently there have been quite a few work being done even in the natural language processing community, especially through these attention models. So when you, for example, when you build a sentiment classifier, alongside with the decision, whether it's positive sentiment or negative sentiment, there are models that would highlight the features with the highest attention that influence most the model when making this particular decision. But again, I think that's a good starting point. But that type of listing up useful features for classification might not necessarily be the type of explanation a domain experts would like to have. If you're a lawyer and if you want to know why this machine learning model says this case is likely to be successful. So we've also built these type of models. But then, I mean, you might not be satisfied just by looking at a set of words with high weights. And you might need more than that. And most of the situations it's not like individual words that are like providing evidence, but the combination, how they've been used in the context. So I again think like providing explainability into like decision support systems built using AI, mainly machine learning and deep learning models, is an important thing, especially in the AI and law community. And I think there should be some kind of a conversation between people who build these models and explanations and the domain experts, kind of end users who are going to use these things. Because, I mean, as computer scientists, we also like provide a lot of like debugging information for our models. But those debugging information are good explanations for the developers, not necessarily for the end user. So I think we need to like have a conversation with the end users to find out which explanations they would like to get out of a system and how we can provide that. And finally, I also like this kind of a nice summary Stuart was putting out. Like, and we talk a lot about like AI safety, AI ethics, and AI explainability, and so on. But I mean, these things should be like, I mean, integrated into AI. Like, we shouldn't have like different sub domains of AI and a group of people, like you were saying that, I mean, group of people like pointing fingers at others saying that you are not providing this explanation, like your models are not safe and ethical and so on. But I think like, I mean, these things should be kind of a thought of from the kind of a starting point when you build these models, rather than like build a model first and then like worry about whether it is safe and ethical and so on. So so that's the type of, I mean, kind of interesting points that I kind of picked up, which I thought would be like interesting to the community, as well as an NLP researcher for me to look further into. So with that, I'll stop. And if there are any further questions in the chat later on, maybe we can pick up. Thank you, Adam. Over to you.
There we go. I'm back on. Thank you, Danishka, for your remarks about that. Shall we turn to Tom?
Okay. So I have to make a confession, which is that I've always had an inherent mistrust for AI and its applications in relation to safety critical systems. So my background is the mathematics of software engineering, formal specification, including deontic logic. This mistrust is built on the knowledge that the modern methods used in AI are based on learning, and therefore they inherently rely on incomplete information. And with safety critical systems, the last thing you want is incomplete information, because that means that you have critical situations where you have no idea what's supposed to be happening, what the system is going to do. Great illustrations of this have been provided by autonomous cars, which seem regularly to find themselves in situations that they have not seen before and don't know what to do. So this is a very worrying situation. However, I'm beginning to change my mind a little bit, in the sense that cyber physical systems are, again, examples of systems which we don't understand completely. And especially when you put cyber physical systems together to make bigger cyber physical systems, you don't understand what's going on well enough to actually build a system which is going to be safe. So the one possible answer to address this problem is something called monitoring. That you don't let the system function on its own, you watch what it does. And when you detect something going wrong, which is another possible point of discussion, how do you know that it's going wrong? If you find that the situation is getting critical and bad things could happen, you intervene in the system. So there is a way around this problem, but it is not yet very well understood. So I think the important message is that one has to be extremely careful about the applications of this kind of technology. The one thing that struck me about Stuart's talk is the idea of a provably beneficial system. Now, first of all, I have no idea what beneficial means. I presume it's something that is established via some utility function that is defined for the system. But then the obvious question to ask is, how do you know that the benefits are properly defined and that you can rely on the benefits being actually beneficial in the human sense and that they work safely? The question that I tried to address before. So I can see that there's a lot of progress in the issues being addressed by modern AI, but I think modern AI is still not addressing the fundamental questions which need to be answered in order to be able to apply the technology. For example, safety. So I would very much like to hear from people who think they are addressing this problem and are addressing it in a fundamental and rigorous manner. I think that's all I should say for now.
Forgot I'm on mute.
Yes.
Tom, thank you very much. Great. Thank you very much. Speaking of systems that have error because of people. So let's go to you, Bertie.
Okay, I've tried to put some slides together, and let's see if I can share them with you. There we go. Can you see that? Yes.
Yes.
Okay, so I've quickly recycled a few slides that I thought might be useful in this context, and it's from a talk I gave late last year on kind of designing reliable, responsible, and resilient AI systems. Just as a little bit more background to what Adam introduced me as, I'm very interested in all kinds of AI as chair of AISB, in particular in ideas around AI ethics, but also I'm a member of the cybersecurity group, and as such, looking at and interested in the security of AI systems, not just safety, but also security. So if we look at these ideas of reliability, resilience, and responsibility, let's have a quick run through. I'm not going to read out the quotes that I put on this slide. You can either read them now, or if you want my slides, I can share them with you later. But when we're looking at reliability of systems, traditionally this is something that uses formal methods, looks at effectiveness, accuracy, maybe efficiency of solutions, ensures availability, needs possibly some sort of explainability. So that is something that we're missing with a lot of the machine learning systems in AI, but also needs awareness of some other factors that might influence these systems. So it includes lots of formal methods that have been developed over decades in computer science, building on mathematical methods. And now we're looking at machine learning, and arguably it makes a lot of sense, and that is something that Stuart mentioned as well, combining various kinds and aspects of AI. So not just looking at learning as the one and only solution, but combining it with more traditional symbolic reasoning. So this could be a way forward to looking at reliability. Now, some years back, people were kind of promoting the idea that a system that is reliable will be helped by simply being a rational system. Rational systems we think we can understand and we know why things happen. So look at this little thought experiment. A game played by these fish, and one fish claims, yeah, I'm a rational agent. The counterpart then says, well, okay, I'm going to act as a rational agent too. And what does that mean? Well, okay, let's play that game. Argument, make an argument, make a move. And the first rational agent makes a rational move according to some rules. Then the opponent will say, well, okay, at some point, my opponent being a rational agent, thinking that I'm a rational agent too, it makes a lot of sense for me to make a move that doesn't seem rational. So that could be formalized in the system as well. And at some point that kind of means that, well, instead of the rational expected move, maybe the other rational agent says, well, I'm going to put that opponent of mine out of kilter and make an irrational move. And that seems to be a rational decision. And by doing so, well, the whole argument collapses and we no longer have a rational system that we can explain fully. So looking further at reliability, with machine learning, we know that we sometimes can introduce biases. There's various types and ways of introducing biases into our systems. That can be automatic, it can be unintentional, but it could also be deliberate. And kind of looking forward to the security aspects of AI systems, deliberate introduction of biases could be or is a vulnerability of AI systems. So that is something that we need to look at as well. And then from that arise questions about quantification or just qualification of what a bias is. And can we find something that counters biases introduced into these systems, or will we have to learn from scratch? Okay, let's move on to responsibility. And again, you'll see some connections to Stuart's talk and some connections to Tom and Danushka's ideas as well. So we've heard the mention of transparency, trust in AI systems. What does that mean? Well, it means we need to somehow design our systems so that the users can have trust in them. That means we need to design ethically, look at privacy not as an afterthought, but as a design component. And that would arguably be something that a provably beneficial method should include, some, well, design component that makes it beneficial by design. And looking at privacy in particular, there's various ways of doing that. I've mentioned here differential privacy, but obviously we don't have time to go into this. But looking at the idea of this two-player game that Stuart introduced, where the AI learns from the human, it is a learning from behavior, and that means essentially the AI will do some surveillance, monitor us in its quest to, well, to learn what our goals are and what goals the AI hence should try to pursue. So that is something that, well, needs to be looked at from a privacy angle as well. And then if we're modeling and reasoning with uncertain and incomplete information, and that's something that Tom just mentioned, then that is something that is inherent to this kind of scenario. Because unlike maybe a partner that I've been with for many, many years, an AI that I introduced into my life just a year ago won't have that background information, won't have that history of what my preferences are and what in a longer term kind of timeline I would probably like as my current goal and aim. So some problems we see there as well. Finally, resilience, and that is something that, well, clearly includes security aspects, robustness of the AI systems. It needs some proactivity in certain circumstances. Something I worked on previously was actually a monitoring solution for patients with dementia. And one of the problems we faced there was simple loss of mobile phone signal. So an AI solution needs to have that proactivity as well to say, well, we need to adjust our reasoning or our methods by knowing that we're moving into certain environments. Clearly, security-wise, National Cybersecurity Strategy says we need lots of increase in capacity, capability, diversity, and various other things. So that's, again, something that for a provably beneficial solution needs to be included. And the question there is, and Stuart mentioned that in his talk, the off switch problem. So can we design resilient systems that still adhere to that, well, that need of an off switch, or is that, or could that be misinterpreted into someone interfering with the well, greater the greater good and the goal that the AI system has? And Stuart has given some ideas there how that can be mitigated, certainly worth looking into. But in general, if we look at research in the past and currently, looking at reliability, responsibility, and resilience again, we can see that, well, there's a lot that has been done in terms of reliability, a lot of work and resources on informal methods, etc. When we look at resilience, again, this has been done for at least a decade. There's quite a bit of research going on. Responsibility, however, is still in its infancy. And as I tried to show before, these, you can't see these kind of isolated from each other. They all intermingle with each other and they need to be seen as, well, part of the whole. So that certainly is something where we need a lot of work. And finally, just a little overview of other aspects where, looking at AI systems, we probably need some monitoring, continuous ethical monitoring of AI systems, especially those that change over time, that adapt to their environment. We need to look at the human in the loop and the skills that humans have that arguably AI will never have, and look at that kind of in a sense of ubiquitous facets of AI, including security, including ethics, including effectiveness, and these kind of things like the formal methods that I mentioned before. And then the question that came up when I looked at Stuart's talk was looking at provably beneficial AI. That reminded me a little bit of something that maybe 20 years ago was a little bit of a buzzword, but never got anywhere really. And that was the idea of proof carrying code. So programs, applications that can carry their own proof of certain properties that they fulfill. And that would be an interesting idea maybe to dig up and try to integrate that. And in the sense of legal requirements, this kind of proof carrying code could be some encoding of legal requirements as well. And that's where I'm going to leave you. So back to Adam.
Great. Thank you very much for those remarks, Bertie. Let's first see what questions that we've got from the audience, if any. So we're turning this over to the organizers. No questions so far. Do you have questions for one another?
Well, if I may, maybe the other panelists can tell me how you define beneficial in a way which allows it to be determined and compared. If you have a provably beneficial system, it means you can model it, you can reason about it, and you can decide as humans whether you've got it right or not, you've implemented it correctly. And these things I just don't understand from what I've heard so far.
I mean, when I heard it, like I thought, like I was trying to connect it to kind of some kind of a utility. So perhaps we had to first define what is a good utility for humans, because there are two agents here, the robot as well as the human, and we are talking about the beneficial for humans. So again, I was not sure, it was not clear to me as well, like how to define the utility. So if any action that increases the utility for the human, I thought it was beneficial. But then maybe I'm just transferring the definition of beneficial to utility.
Well, at least that is a precise definition. You have a utility function, right? And its output increases or decreases as appropriate as a result of applying these rules, okay? Well, that's something to work with, okay?
I mean, there's a lot of philosophical problems around that. The old problem of variance of utilitarianism. What is okay to do? Can I kill all my useless neighbors to harvest their organs that would match somebody else who, according to some utility function, is more likely to benefit society?
I think we make decisions like that all the time, right? And the people who make the wrong decisions are called criminals, war criminals maybe, right? So I think those kinds of decisions can be made. People can decide that they like this way of characterizing things, but first you have to come to some initial agreement about what the rules are.
Yeah, maybe like
I think if I could just sort of make one remark, one of the messages that I got about this notion of what's provably beneficial. So let me just focus on the provability notion, right? Because I think that you're making the right point that if you're going to start to use that language of proof, then you need to say, what's the model and how are you doing reasoning and what are its properties? And that starts to take you into a whole range of thinking about formal systems. I think the particular place where he used that in the talk was about the off switch, right? There's a little diagram and a little discussion, And he said, oh, if we do it this way and that way, and given opportunities for uncertainty introduced into the model, then we can prove, and it was more of a demonstration rather than a proof. It's a demonstration. We can talk about this being beneficial for humans because the nature of the system wouldn't be autonomous in terms of saying, I'm going to bar the off switch from functioning. Because I have uncertainty, I can always allow a human to choose to turn it off. So that was the one place where he really used this phrase of provability with respect to what's beneficial. The rest of the discussion, as far as I was hearing it, was that the notion of beneficial is derived entirely by kind of monitoring the population and their behavior about what they say, what their behavior, monitoring the population in terms of their behavior, and from that, inferring their preferences, right? So inferring from individuals and inferring from collectives. And that's not a matter of proof. That's a matter of kind of some systematic method of accumulating, individual and collective behavior to kind of sum to saying, okay, at this point, we'll accept this as a preference of those individuals or those groups, right? That doesn't sound to me like proof in the sense that I'm sure you're thinking about it, Tom. But it is a kind of it's another notion of how to gather that information. So I think we have to be careful about how we're using that notion, and I'm not sure that he really sort of worked on that point very clearly either.
Yes, it's a demonstration, not a proof.
Yeah, it's a demonstration. It would be better to talk about it as a demonstration. And there were a range of issues that he discussed about, how do we get from people's actions to their preferences. Let me also interject another point. The reason why I thought this was interesting to talk about here is because there are, in the AI and law community, a very prominent subgroup for whom preferences and for whom values, especially in the law, is the key. Whether it's in argumentation or case-based reasoning or various kinds of areas like that. So what I thought was interesting about the talk was to really put human preferences at the center of development, and sort of derive things from that. How we identify preferences from people's behaviors is not entirely clear. Whether we do it, as Danushka was suggesting, by accumulating annotators' data and trying to converge on agreed annotations, whether it's of behavior or of text, that's one method, but we have to come up with different methods for extracting or abstracting preferences from behaviors. But I thought that was an interesting point to kind of emphasize.
Mm-hmm.
I thought, Tom, maybe I'd sort of ask you, because you've done a lot of work on fault-tolerant systems and allowing for systems that will do wrong and yet will correct even if their behavior was uncertain. I wonder if you could make a few remarks about that, if you think that's appropriate here.
Well, it is appropriate because faults occur when something unexpected and potentially bad happens. And people realized at some point that you cannot build a perfect system which will always behave correctly, even if you know what correct means. And that's always a problem. So the monitoring idea comes from fault tolerance. It's one of the general mechanisms that people use to try to deal with faults in systems. If you cannot have an explicit mechanism in the system itself, which deals with anomalous situations, then you have to be able to watch the system and determine when an anomalous situation has occurred. You have to know what an anomalous situation is and then act on that. shut the system down, take corrective action of some kind, and so on. So fault tolerance is a good model for dealing with these kinds of situations.
There is an analogy, actually Russell mentioned this in his talk, wasn't quite fault tolerant, but he mentioned active learning, which Danushka may be familiar with. And there's been a little bit of work in the AI and law community in active learning where you're constantly feeding back results, or even questioning about the annotation of the data to users. And you're using this kind, and so therefore it's really it's a version of monitoring in the learning cycle, right? And so that's an interesting sort of connection between how machine learning is done and some of these notions about monitoring. It's not, again, not so much about fault, but it is something about the judgments about either what the model looks like or what the data looks like.
Mm-hmm. Yeah. There's some possibility there, although self-monitoring systems, I think, are not the universal solution, because you need external judgment sometimes to decide that something really is going wrong.
Right, great. So let me take a couple of questions from the chat. We've got two coming in here. We have a question from Julio Marengo, who's the conference organizer. Hello, Julio, nice to see you. From a multi-agent system perspective, do you think it's feasible, as Russell seems to believe, that an observable collective preference is feasible, right? I have a remark to that, but let me pass it over to you first. Anybody who wants to address this, if anybody?
Let somebody else address it.
Yeah, I'll give it a go. It's really a hard problem. We can see with just two actors or agents, they can have diametrically different opinions, and it could just be something like, I don't know, my favorite snack might be chocolate, but my doctor tells me it's very bad for my health to eat chocolate. So those are opposites. How can we can only find some kind of consent and say, well, okay, I'll give up on chocolate and my doctor won't nag me anymore. But kind of going into larger groups of agents, well, essentially that's what societies do and what norms are there for, but they're so high level that that's not really the preferences that Stuart was talking about, and it won't give me my coffee in the morning, for example. It tells me what to do and what not to do in terms of what's societally acceptable, and that's about where we can get, I believe.
But maybe his notion of preference as being individualistic, small numbers, etc., is infeasible. And so the only view you can take is this larger population statistical one.
I mean, there might be like kind of a smaller worlds or like smaller subsets of preferences that you can make feasible, but not everything. So that's what I think.
Yeah, I think, I guess one of the topics that came to mind along these lines from listening to the talk is whether there are structures and relationships amongst preferences, and how would you kind of look at these as at different levels of abstraction. And I guess to me, the analogy that comes to mind, because I first started off in linguistics, is, language typologies, both having to do with, the words and the pronunciation and the syntax, that, you can look at languages in lots of detail and people will say things like, well, there's infinite variation amongst languages. But when you're a linguist and you study the relationships, you find out that there's quite a lot of structure and a lot of systematicity amongst that. So the surface variation, in fact, hides a great deal of structure and consistency among these things. That's not asserted on populations, but somehow arises from human behavior. And the question is whether preferences could similarly have some kind of structure that we haven't really done very much work to identify in order to arise to that level of the norms, right? That's the level at which we identify sort of large scale preferences. And that's really at the level of where legislation, regulation, and case law is made, right? It's trying to assert larger scale norms. Although, for instance, case law has a lot to say about detailed behavior, right? That's what they do in cases. You're very naughty in that specific circumstance doing that specific thing. That's interesting because there's a specific legal preference about that specific kind of behavior. So there is a lot of information lying out there, and you wonder if we can do more analysis about that. Let me turn to another question from the audience, or we have two more coming up. This is a question from Thorne McCarty. Hi, Thorne. Stewart's main point was to have AI systems pursue goals that optimize human preferences. But we find ourselves in a quagmire. I think we've just been talking about that a little bit. I think if we try to operationalize this idea, Stewart's later slides looked at the difficulties of determining just one person's preferences, what Bertie was referring to, I think, but then talked about determining group preferences for the entire population of the world, kind of along the lines of what we were just talking about. So there is, a finger on a very large scale problem. And, at some point, we probably have to tackle that. The question is, how might we do this, right? It's a bit sort of doing large scale requirements engineering of a very large scale problem in that sense, right? And that might be a reasonable analogy. And you wonder if we could start to take some tools from requirements engineering and try to make some small use cases to figure out ways in which we could understand at least this kind of problem better. So any further comments along those lines about this relationship?
Well, I think a big takeaway from Stuart's talk is what he started with, the probabilistic programming angle. And this is something, again, that dates back many decades, where we ran as computer scientists into problems of, undecidability of certain problems if we want a precise answer, but maybe we can approximate these with probabilities in the sense. And when we have this setting of, incomplete data, incomplete information, again, old ideas of belief sets, belief functions, what is my belief in a certain property, that could be a way forward to bring a little bit more transparency and not just do the black and white or the yes and no, and let an AI system say that, well, I don't know, but I've calculated a value that gives me so and so much certainty. And we then need, as humans, to interpret that in the way that the system works, that what we know about the system and the context in which the system works.
Yeah, thank you, Bertie, for raising that. One thought that occurred to me along those lines when you raised probabilistic reasoning is that Pearl, who did a lot to bring Bayesian reasoning, to greater prominence, has turned to looking at sort of formal approaches to causal reasoning in particular, because it seems very difficult to really adequately represent causal reasoning in probabilistic terms. And I was a little bit struck that Russell raised this and emphasized probabilistic reasoning, and yet didn't really talk at all about Pearl's approach, which is a formal theory, at least an attempt at a formal theory of causation, which has its own problems. But it is interesting to make that effort. There is a whole branch of logic that tries to reason systematically with causation. And Tom, I see that you have something to say.
Well, it's another observation, a different observation, that the probability we're talking about here is not Bayesian probability. It's Baconian probability. I don't know if any of you have heard about Baconian probability, but it was investigated by quite a lot of people, including John Maynard Keynes, Jonathan Cohen, and it's basically the logic or the mathematics of confidence. People like Carnap were interested in understanding the notion of confidence in a scientific theory and why it's robust to small experiments which seem to contradict a scientific theory. It's also the reasoning behind law. This Baconian probability is the reasoning behind law. So, for example, two people asserting the same idea do increase your confidence, right? Whereas in normal probability, you don't get any increase in probability. So this kind of setting might be a more fruitful one in which to study these notions of preference. Because what we want is to build a model of people's preferences in which we have some level of confidence and which is robust to small changes in individual confidence, in individual preferences. I think that would be a very interesting line to pursue in this context.
Thank you very much for that distinction. That's a good point. It's not something that had really come to mind as a key point, so I was a bit distracted by that. Great. Any other? We've got one more comment I see from Thorne. Further comment from Thorne McCarty. Here's an argument that Stewart's proposal will have disastrous effects. That's exciting. So that'll be an exciting note to end on. Look at where we are today from following human preferences, climate change, wars and revolutions. True, right? So the AI systems trying to advance these preferences could become an amplifier of the worst tendencies that go with the human race. So, that's the reason why we have to have philosopher kings and base our preferences on their preferences rather than leaning towards the consumption society that has given us the problems that we currently have. So it is the tendencies of small and large communities. We also have the effect of, small communities. Small communities can have outsized effects. You can talk about, the impact of small radical groups on populations and the security protocols that happen when just one person wears a shoe that's a bomb and the rest of us are subjected to inspections for decades. So there's an interesting issue to raise there. Thank you for that comment, Thorne. So,
Adam, are you arguing against democracy?
Oh no, it's the best of difficult things.
Yes.
The advantage has been that it balances things out somehow over time with some problems.
Mm-hmm.
So if that's perhaps one of the reasons, how preferences are going to work, but it would be interesting to have clarity about that. So I think it's a very, it's an interesting global discussion. I think it's interesting in the context of AI and law to kind of be considering these things. There's been an enormous interest in machine learning approaches, classification of legal texts and things. And I think it's very well worth, the AI and law community having their eye on these really large scale, very difficult topics that really clearly relate to legal reasoning, what legislation is about, whether we can automate lawyers or judges or legislatures or these kinds of things. So it's certainly worth talking about further. I'd really like to thank the panelists for joining us and giving us their thoughts and having a bit of an exchange. It's very good to see familiar faces from different places. Thank you very much. Thank you to the audience. And I guess we'll call that a day. Thank you very much. Goodbye.
Thank you. Bye.